Last lecture, we talked about multicellularity, and when a cell exists in a community of cells, whether they're the same type or different types. And one of the things I emphasized was how useful it is to spot asymmetries inside a cell and around a cell. Asymmetries in these communities or in the compartments within a cell. So we're going to practice this week using our data set. Spotting asymmetries in your cell, both within the compartments and then trying to attribute that perhaps to the neighborhood around that cell. So I'll give you a few examples of what I mean. But first of all, let's define the axes of the embryo we're working with. So to the right of the panel or the screen, that is the front, the head region of the embryo. So that's the anterior. Anterior is on your right. The opposite is posterior. That's going to be on your left. And then let's find the back and the belly, or the dorsal and the ventral sides. So let's take a look at Pay attention to the numbers at the bottom of your screen. They appear here at position. You have 3 different digits. The very last one, here 666, that tells you about the height in the dorsal ventral axis. So if we take it all the way to the extreme, 900 something, this is the very dorsal end of the embryo, the back. And then if we go all the way, scroll deep to the other side, we get the ventral side. You see how the number goes down to in the hundreds. So the low number, the third number here, that is your depth along the dorsal ventral axis. The lower numbers are more ventral, and the higher numbers in the 900s is the dorsal side. So that tells us anterior, posterior, and we're somewhat in the middle of the embryo when we're in the 500s. The last axis is the left-right axis. So if this embryo is laid like this, back, dorsal, ventral, anterior, posterior, then the top becomes your left axis and the bottom becomes your right axis. So these are the axes we're talking about: front, anterior, posterior, left, right, and then dorsal and ventral. Let's practice a little bit. Let's take this gut cell over here. Let's zoom in a little bit. And we can see already an asymmetry. It's not a sphere, it's more elongated. It's like a elongated cuboidal shape. And then within the cell, we can see that the nucleus is on the left side of the cell rather than on the right side. That's an asymmetry. And then if we go to the very top of the cell, we see a lot of compartments. Then we go down. We also see compartments, but no striking differences along the dorsal ventral axis. Although, no striking differences in my eye at least. So the main difference, there is actually a difference now that I look at it. If we go to the very ventral side, so where the numbers in this third position decrease to the minimum within the cell, this is the ventral side of the cell. Then we start to see the nucleus, then we get midway in the cell, and then we still have more of the cell all the way to the dorsal end. So it may seem that the nucleus is not only asymmetrical in its position towards the left side, but a little bit towards the ventral side. So it's almost like in the left ventral corner of the cell, more or less. So that's an asymmetry. You can easily pick out the position of the nucleus. And then we have to ask ourselves, well, why? You can wonder, why is the nucleus on this side of the cell? You can start to formulate a hypothesis or even speculate and say, well, there must be a neighbor on the left side that is different than the neighbor on the right side. So let's look at it. When you look at your cell, look at its neighbors as well. So the neighbor here, if you go to skeleton and make sure that all of the boxes are checked by clicking at roots, then you can get to identify the cells around your cell. So if I go to the right plane, I find this marker appears. If I click on it, it tells me what this cell is. It's a gut cell in the gut folder. Okay, so there's a gut cell on the left side of my cell that I'm looking at. What about on the other side? Well, there are two cells on the right side. Well, the cell that is touching it is actually not in the same plane, but here it is. So we got this purple marker over here, and that is not a gut cell. In fact, it's in the other tissue category. If we go back to the cell I'm looking at, right here, I can also see that it's touching two other cells. And can I get that marker? Here we go, here's a marker. So on the right side we have an other cell, but we also have a muscle cell over here. But on the left side we have a gut cell. So in terms of neighbors, there's also an asymmetry there. Gut cell on the right side, which happens to be the half of the cell that has a nucleus, and the other half that doesn't have the nucleus is facing non-gut cells. So right there, you can identify an asymmetry within your cell, and then identify asymmetries in the cell neighbors. And that becomes sort of food for thought. Could it be that the nucleus is the cell is organized so that the nucleus of a gut cell is closer to the other gut cell that is neighboring it? Perhaps. That can start to become something you can perhaps articulate into a hypothesis and then test. Okay, for example, if you can manually dissect these embryos and flip the cell, would the nucleus then move to be closer to the gut cells? That's some kind of cell manipulation could be one way to test this. Very difficult in this case, but you can start to think of ways to test a hypothesis about why is the cell asymmetrical in this way. So this is the first kind of asymmetry I'm pointing out in terms of nuclear position in your cell. Actually, the first one was the shape, how it deviates from a spherical shape. And then in terms of compartments, the symmetry that stood out for me was the nuclear position. And then you can look at the neighbors. We looked at left and right and saw how the left side has a gut cell, the right side does not. Posterior, this is a gut cell. You can see from the marker, it's black in color. And on this side, there's also another gut cell. So it's surrounded by gut cells, except for the right side. That's a symmetry. Let's take another example. Let's take the example here. Oh, here's an interesting one. Let's go here. And let's look at Annie's cell. Now, this is a very interesting cell. This is, Annie is in the pharynx group. So this is a pharyngeal cell. Now, look at the plasma membrane of the cell. It's very squared shaped like. Right? It's almost like a cube, to a degree. Right? And the nucleus is smack in the middle. Okay, so it's not asymmetrical in terms of nuclear position necessarily. Here's the bottom of the cell, and here's the top of the cell, and the nucleus is placed in the middle. Okay, where's the asymmetry there? But look carefully, look carefully. Let's go to the very top of the cell. okay? And then go down, down, down. You see the nucleus, go down more to the ventral side. And then notice this. Notice where the lipid droplets are. You got 3 lipid droplets on the ventral side of the cell. And then here, 2 more lipid droplets. Then we see the nucleus. Okay. And now, no more lipid droplets. And in the dorsal side, this doesn't really look like a lipid droplet because it's like this cloudiness. And there seems to be a partial membrane around it. There is a membrane around it. So this is not a lipid droplet. So in this pharyngeal cell, there's a symmetry in the position of lipid droplets. They're on the ventral side of the cell. Interesting. How come? I don't know the reason, but let's investigate the neighborhood of the cell. What kind of cells are around it? Especially, what kind of cell is neighboring on the ventral side, and what kind of cell is neighboring on the dorsal side? So if we go to the dorsal side, and the cell ends, and then let's see, there's a cell crawling over it here, and over there, and this is green, so it's also a pharyngeal cell. Pharynx, okay, that's on the dorsal side. Well, what about on the ventral side? Here's our cell, and here are the lipid droplets. What's on the ventral side? Is it also a pharyngeal cell? I don't know, I haven't tried this yet. So here's a cell that's crawling over. Well, this is a big cell. So here's Annie's cell, and then you see the cell membrane of the cell on its ventral side reaching over. And here's the nucleus of that cell. Are you going to be green, or which color are you going to be? This is the cell on the ventral side, and it is not a pharynx. It's an excretory cell. So there's a symmetry in the neighbors of the cell as well. The side of Annie's cell that has the lipid droplets is facing the excretory cell neighbor. But the dorsal side, which doesn't have any lipid droplets, is facing another pharyngeal cell. Very interesting. Could that be connected somehow? Could being next to the excretory cell mean that this pharyngeal cell is receiving signals that are making the lipid droplets appear there? That's the beginning of an investigation, but first you have to spot the asymmetries. Okay, let's take one more example. Then I'll let you do this with your own cell and report back what kind of asymmetries you saw and how those asymmetries may or may have not corresponded to an asymmetry in cell neighbors on the side of the asymmetry. And make the instructions will clarify more. But let's practice this one more time. Let's take a random cell. I'm going to challenge myself this time. Okay, so I'm closing my eyes, I'm scrolling up and down, and then I'm clicking somewhere. This was John. Let's see, John has a seam cell. Okay, seam cell. Let's let it buffer or download. Okay. Is it a seam cell? Let's confirm this. Yes. Okay, so first of all, there's a glaring, obvious asymmetry, not inside the cell, but in the neighborhood of the cell, which is the cell is surrounded in 3 directions, or in all directions, by other cells. But on the right side, it's touching the cuticle. It's not touching cells on this side. So that's an obvious asymmetry right there. It's not surrounded fully by cells. But one of the sides, the right side, is actually cuticle. Now let's look inside the cell. And what main asymmetries can we detect, if any? A lot of compartments, a lot of droplets, dark, densely stained and lightly stained and intermediately stained. Nice mitochondria. Golgi body is very evident here. And then the cell ends here. I see lipid droplets, dark and light, on both sides. And then we have the nucleus. And then we have lipid droplets. Look at this endoplasmic reticulum. Ooh, look at this web of endoplasmic reticulum. This network is so intense here. So I'm going to, on the fly, formulate a hypothesis. Endoplasmic reticulum is asymmetric in that it is more towards the right side. Now I'm going to test it by scrolling a little bit more and see if that holds true. I think it's holding true. There's a lot of endoplasmic reticulum on the right side. Now it's true that I have endoplasmic reticulum here as well and here as well, but let's look on the left side. Here I have two big lipid droplets. Here I have endoplasmic reticulum, but not as much as the right half of the cell. So I would say that here there is an asymmetry in the abundance of endoplasmic reticulum. Excuse me. Abundance of endoplasmic reticulum on the right side of the cell. And that corresponds with an asymmetry in that this is the side of the cell that's going to be excreting a lot of proteins to help form the cuticle of the worm. In that sense, the asymmetry in the compartments on the inside, see the nucleus is on the left side and the endoplasmic reticulum more on the right side. That asymmetry internally may correspond to the neighborhood of the cell, in that it is surrounded by cells, except for one front, the right side, where it faces the cuticle, and maybe that's the destination of a lot of the proteins that are being translated in the endoplasmic reticulum and then secreted by exocytosis. Beautiful, beautiful. Oops, we left the cell. Here's the cell. Oh, I'm sorry. When I said the nucleus is here, this was actually another cell. The cell membrane is here, but John's cell is right here. Here's the nucleus. And there does seem to be, if you were to cut this cell in half, the endoplasmic reticulum is more on the right side than the left side. Out of curiosity, what kind of cells are surrounding this? So we have a hypodermal cell here, and we have another seam cell here. I'm going to seam cell. And then what about the other side? We have here a red cell. That's a muscle cell, if I'm not mistaken. No, it's a neuron cell. And then here, what do we have here? This cell, this neighbor, is purple. Oops. That is an other cell. Okay, specifically, that's a H1L. I don't want to give you wrong information. Elegance cell list. It's a seam cell, blast cell, so it becomes a stem cell. So stem cell after hatching, but now it's a seam cell. Neuron and hypodermal cell and seam cell surrounding this cell from three directions, but the direction on the right side doesn't have any cells. And that's the one that corresponds with the asymmetry. So these are three examples of detecting asymmetry in your cell and asymmetry in the neighborhood, in the community around that cell. That's today's application, and then you're going to write a reflection about the asymmetries you've noted inside the cell in terms of compartments and the asymmetry in neighbors around the cell. And we'll leave it there for this week. Happy exploring.